All right, let's give you some feedback on these two warm-up problems. Now, the first one is sine plus cosine times tangent. And probably one of the most common steps for a student to take is to recognize that that tangent, which we turn to green, that tangent is equal to sine over cosine. Now, when you change tangent to sine over cosine, but you leave everything else as it is, then we have all sines and cosines. And this cosine, they will cancel, they will divide. Now they divide to be the number 1, but it's just like now 1 times sine. And so since we have a sine and we just got another sine, if you add them together, you have 2 sines. Sine plus sine is 2 sine. Now there is another way to do the problem. I saw some of you notice that in the original form, cosine times tangent is an identity. That's right, it's equal to sine. So if you recognize that this is equal to sine right away, well, now we're back to sine plus sine. Okay, it takes us to the same answer, 2 sine. It's just a little way to avoid the canceling. We still end up with sine plus sine. Now, the second problem, a lot of you wanted to cancel out these cosine squareds. And in fact, they do cancel out, but you also have to split and you have to take the cosine squared to the other part of the numerator. So we actually have to divide it to both. Before we do that, I want to show you a better way. A couple of you noticed that the numerator is special. The numerator is the beauty, sine squared plus cosine squared. And of course, sine squared plus cosine squared is equal to 1. Now we're looking at a whole different problem. It's 1 over cosine squared. 1 over cosine squared is in the same family as 1 over cosine. It's a reciprocal. So 1 over cosine is secant. That means 1 over cosine squared is secant squared. So you want to cancel the cosine squareds. Well, you have to use a Hart method. You have to divide or split the cosine squared to both parts of the numerator. Now, you get sine squared over cosine squared, okay? And you get cosine squared over cosine squared. But what we want to understand is that that is equal to 1. That is equal to 1. How about sine squared over cosine squared? Have you seen that before? That's right, that's equal to tangent squared. So we're staring at tangent squared plus 1. Now, you don't have to have the identities memorized, but soon you're going to recognize that tangent squared plus 1 is in your identity book, and it's equal to secant squared. Of course, we end up with the same answer. That second problem, I like that one because that's a little segue into our next lesson. Our next lesson is going to involve lots of fractions. And what you saw here was like a Hart method. Okay. In fact, the problem up above had a fraction. And what you saw in that fraction was just some simple canceling. So we have canceling. We have like a Hart method. And homework problem number 6 is actually another example of something we can do with a fraction. Some of you asked if we could go over number 6. So let's follow through with that. Okay, sometimes when you see a problem, you need to also see the algebra. And the algebra for this problem is, well, we could do the distributive property. I say we could do the distributive property. That is if we're going to start with algebra. Now, when you do that, you seem to just kind of get a mess. You get cosecant minus cosine squared times cosecant. What are we going to do with that? Okay, not a whole lot until we start to change these reciprocals. Now, what I want you to see here is that I'm choosing to only change the cosecants. And when you change the cosecants, you get sine in the denominator. Over here, you get cosine squared over sine. But notice that I left the cosine squared in the numerator. Now what? Well, as we're going to learn in our next lesson, we have common denominators. If you have common denominators, you're allowed to subtract the numerators. So we subtract 1 minus cosine squared, keep the denominator common. we're back to 1 minus cosine squared. I say we're back to it because it's interesting. That's kind of where I started. Okay, now 1 minus cosine squared is an identity. 1 minus cosine squared is sine squared. So I'm staring at sine squared over sine. And we get some cancellation. We get the sines to cancel. Of course, there's 2 of them up in the top, so I'm still left with sine. Now, there's another way altogether to do this problem. Instead of doing the distributive property, instead of doing algebra, which there was nothing wrong with it, but instead of doing it, you can actually just flip your cosecant right away. Now, if you flip your cosecant right away, you're going to meet us at this step. You're going to have 1 minus cosine squared, but you're going to have a sine in the denominator. Okay, and it leads us to the same answer. How about number 4? Some of you asked about number 4, so let's talk about that. Cosecant over secant times tangent. Now, there are a few ways to go about this problem. I'm going to choose to use that reciprocal flip method. That is, I'm going to only focus on moving secant up and cosecant down. Now, when secant moves up, it turns into a cosine. It has to change. When cosecant moves down, it turns into a sine. Cosine over sine times tangent. Now, not that you do this all the time, but tangent certainly is equal to sine over cosine. And so if I notice that I can turn this all into sines and cosines, makes it really easy to cancel these sines. Also cancel these cosines. What I'm really doing is dividing, and of course everything divides to be the number 1. And how about number 3? Okay, another good problem. It looks kind of simple, but it's a fraction. No fractions are really easy problems. I've heard students say they would change tangent, and I would say to you, fine, change tangent to sine over cosine. We just need to understand how to deal with the double fraction. Obviously, we have a big fraction. That was the original problem, but now we have a fraction within the fraction. Let's focus on this big fraction. It's a division sign, right? It's really like saying top divided by bottom. It's a division problem. I'm going to change this division sign to a multiplication sign. How? Well, I'm going to change this division sign to a multiplication sign. How? Well, by multiplying, here we go, by multiplying by the reciprocal. There's a rule that says dividing is the same as multiplying by the reciprocal. And so I can use that rule to basically eliminate this original big fraction. It's a division sign. It's the same as multiplying by the reciprocal, which is 1 over sine. Now, that allows these signs to cancel, and it leaves us with 1 over cosine. Except 1 over cosine, you shouldn't leave it in that form. You should change that to secant. So we end up with 1 over cosine equaling secant. Okay, that gets us started with kind of our first batch of simplifying problems. For our next lesson, we're going to continue this. What you'll find is that we start to look at some problems that are a little bit more advanced.